start by checking all ground fault circuit interrupter outlets on that wall and reset them. Next, carefully inspect the wire connections. Remove the cover plate from each outlet and inspect the wire connections, ensuring that they are tight and secure. Then test the circuit with a voltage tester. Use a voltage tester to verify the voltage at each outlet and switch. This will help determine if the issue is with the wiring or the devices themselves. Consider using a thermal imaging camera if available to inspect the wall for any hot spots, which could indicate potential shorts or overloaded circuits. Isolate the affected area by turning off the circuit breaker that supplies power to the affected outlets. This will isolate the problem and prevent any further damage. If you need to explore the ceiling, consider using a fish tape. If possible, insert a fish tape into the wall cavity to try to locate the source of the stray voltage. If other methods fail, carefully drill small exploratory holes in the ceiling to gain access to the wiring. Make a note of the location of the holes for future repair. Now address the exterior light issue, paying special attention to the melted switch. The melted spot on the switch box indicates a serious issue. Replace the switch immediately. Repair the ground connection by splicing together the severed ground wires using a wire nut and a short piece of insulated ground wire. Finally, inspect the light fixture, verifying that the light fixture is securely fastened and that the connections are not loose. Adhere to safety precautions. Ensure all power is disconnected before performing any work. Wear gloves and eye protection. If you are not comfortable or unqualified to perform these repairs, contact a licensed electrician. Let's delve deeper into each of these steps. When checking the ground fault circuit interrupter outlets, look for any signs of damage or discoloration. Press the reset button firmly to ensure it engages properly. If the ground fault circuit interrupter trips immediately after resetting, it indicates a ground fault condition that needs further investigation. When inspecting the wire connections, pay close attention to the type of connection. Are they back-wired, where the wire is inserted into a hole in the back of the outlet, or are they connected to the screw terminals on the side? Back-wired connections are generally less reliable and more prone to loosening over time. Ensure that the wires are properly stripped, with enough bare wire exposed to make solid contact with the terminal, but not so much that the bare wire extends beyond the terminal and creates a risk of shorting. When testing the circuit with a voltage tester, use a reliable tester that you are familiar with. Test the tester on a known live circuit first to ensure that it is working correctly. Measure the voltage between the hot and neutral wires, the hot and ground wires, and the neutral and ground wires at each outlet and switch. A normal reading between hot and neutral should be approximately 120 volts. A reading significantly lower than this could indicate a voltage drop caused by a loose connection or a problem with the wiring. A reading between neutral and ground should be close to 0 volts. A higher voltage between neutral and ground could indicate a problem with the grounding system. When using a thermal imaging camera, look for areas that are significantly warmer than the surrounding wall. These hot spots could indicate a loose connection, an overloaded circuit, or a short circuit. Remember that thermal imaging cameras only show surface temperatures, so the actual temperature of the wires inside the wall could be much higher. When isolating the affected area by turning off the circuit breaker, label the breaker clearly so that you can easily identify it later. You may also want to turn off any adjacent breakers to ensure that the entire circuit is de-energized. When exploring the ceiling with a fish tape, use a flexible steel fish tape that is easy to maneuver through tight spaces. Push the fish tape into the wall cavity and try to feel for any obstructions or changes in direction. If you encounter an obstruction, try to work the fish tape around it or use a different angle of entry. If you are unable to locate the source of the stray voltage with the fish tape, you may need to drill small exploratory holes. Choose a drill bit that is small enough to minimize damage to the ceiling, but large enough to allow you to see inside the wall cavity. Drill the holes carefully and slowly, and be prepared for dust and debris to fall out. Use a flashlight to inspect the inside of the wall cavity, looking for any signs of damage or loose connections. When addressing the exterior light issue, start by inspecting the light fixture itself. Look for any signs of damage, such as cracks or broken parts. Make sure that the light bulb is properly seated in the socket. If the light fixture is old or corroded, it may need to be replaced. When replacing the switch, use a switch that is rated for the correct voltage and amperage. Make sure that the switch is properly grounded. Connect the wires to the switch terminals according to the manufacturer's instructions. When repairing the ground connection, use a wire nut that is the correct size for the number and gauge of wires being connected. Twist the wires together tightly before applying the wire nut. Use a short piece of insulated ground wire that is the same gauge as the existing ground wires. Secure the wire nut with electrical tape to prevent it from coming loose. Consider the potential causes of the stray voltage. Firstly, a loose neutral connection is a common culprit. A loose neutral can cause voltage fluctuations and create phantom voltages on circuits. Secondly, induced voltage from nearby energized conductors can also cause stray voltage readings. Thirdly, moisture intrusion can create conductive paths that lead to voltage leakage. Fourthly, damaged or frayed wiring can also cause voltage leakage. Consider the potential causes of the melted spot on the switch box. Firstly, loose connections can cause arcing and heat buildup, leading to melting. Secondly, overloaded circuits can cause excessive current flow, leading to overheating. Thirdly, improper wiring or undersized conductors can also cause overheating. Be careful when cutting exploratory holes. Firstly, locate the studs or joists in the wall or ceiling before drilling to avoid damaging them. Secondly, use a stud finder to help locate the studs or joists. Thirdly, wear safety glasses to protect your eyes from dust and debris. Fourthly, be aware of any hidden pipes or wires in the wall or ceiling before drilling. Consider further diagnostic techniques. Firstly, perform a voltage drop test to identify any points of high resistance in the circuit. Secondly, use a multimeter to measure the current flow in the circuit. Thirdly, perform an insulation resistance test to check for any leakage current. Fourthly, consult with a qualified electrician for further assistance if needed. Consider the impact of shared neutrals. In some older electrical systems, multiple circuits may share a common neutral wire. If the neutral wire becomes loose or disconnected, it can cause voltage imbalances and create problems on multiple circuits. Identify any shared neutral circuits and inspect the neutral connections carefully. Furthermore, consider the potential for backfeeding. Backfeeding occurs when power from one circuit is inadvertently fed into another circuit, typically through a multi-wire branch circuit. This can create dangerous voltage conditions and damage equipment. Inspect all circuits for potential backfeeding and take steps to isolate them if necessary. Consider the effects of aluminum wiring. Aluminum wiring was used in some homes built in the 1960s and 1970s. Aluminum wiring is more prone to corrosion and loosening than copper wiring, which can lead to electrical problems. If your condo has aluminum wiring, take extra precautions to ensure that the connections are tight and properly maintained. Use antioxidant paste on all aluminum wire connections to prevent corrosion. Also, consider the age of the wiring. Over time, wiring can deteriorate due to heat, moisture, and physical damage. Old wiring is more prone to insulation breakdown, which can lead to shorts and ground faults. If your condo has old wiring, it may be time to consider replacing it. Remember the importance of safety. Always disconnect the power before working on any electrical circuits. Use properly insulated tools. Wear safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician. Consider the local electrical codes. Electrical codes vary from place to place. Make sure that you are familiar with the electrical codes in your area before performing any electrical work. The National Electrical Code, or NEC, provides a comprehensive set of standards for electrical installations. Consider the long-term implications of your repairs. Make sure that your repairs are done properly and that they meet all applicable safety standards. Improper repairs can create dangerous conditions and lead to future problems. If you are unsure about any aspect of the repair, consult with a qualified electrician. Remember to document your work. Keep a record of all the repairs that you have made, including the date, the location, and the details of the repair. This will be helpful if you need to make future repairs or if you ever sell your condo. In summary, troubleshooting electrical problems can be challenging, but by following these steps and taking the necessary safety precautions, you can often identify and resolve the issue. If you are ever unsure about any aspect of the repair, consult with a qualified electrician.